All right, let's review over what we talked about yesterday. Okay, so yesterday we talked about orbital notation diagrams. Okay, orbital notation diagrams seem kind of confusing at first, and then we kind of get the hang of them. Make sure, I would advise you to have your energy level diagram sheet out. Okay, that's something we will use. Okay, that is something we will use. It's kind of a cheat sheet right now. No, you don't get to use that on your test, but you'll learn how it works by the time you do it. Okay, no, you don't have to memorize it. I'll show you how to cheat and how to learn it. Okay. So energy orbital notation diagrams use arrows as electrons. Okay. Remember we have to obey all our rules. We have to obey Pauli exclusion principle, alpha principle, Hund's rule. So the big thing with like Pauli exclusion principle is you need to have different spins. Did I give you one? One was yesterday, one today. Okay. Yeah, one's yesterday, one today. Okay. Boron was the one today. Yes, sir. So we're going to follow our rules. Big thing is there is the spin. Okay, the spin quantum number indicates is either positive 1/2 or negative 1/2. A positive 1/2 spin is indicated by an up arrow. Okay, a negative 1/2 spin is indicated by a down arrow. You can see from the energy level diagram, S has 1 space, P has 3 spaces, D has 5, and F has 7 spaces. Okay, so our rules for determining our orbital notation is you need to determine the period, block, and number of electrons. Okay, so we'll do that, and then you're going to draw the orbital notation up to and including the period and the blocks, and then use arrows indicating the electrons. So let's draw an orbital notation. Okay, let me just randomly pick one. Let's do nitrogen. Okay, so let's do nitrogen. So our first 3 steps. So we're going to draw the orbital notation for nitrogen. Someone tell me the period, the block, and the number of electrons of nitrogen. Period, level, and block. Need your periodic table out also. Period 2. Okay. We agree with that statement. Period. Let me find my mouse. Period 2. You said P block? Yeah, P block is in groups 13 through 18 is the P block. Very good. Seven electrons, okay? Get all 3 of the, oh, that's a bad E. E minus stands for electrons. You get all 3 of those things from the periodic table. So then you get your energy level diagram out, okay? You get your energy level diagram out, and I'm opening it up. And so that's steps 1, 2, and 3, okay? We just did steps 1, 2, and 3. It doesn't really matter what order you do them in. So then we're going to go to our energy level diagram. Oops, still not on that screen. And you are going to come down here to this, okay? And step 4 tells you you're going to draw up to the period. So this whole row right here is period 1. The row above it would be what? 2, 3, 4, 5, 6, 7. Okay, so the S indicates the period, okay? That's a question from one of your homeworks. The period, the principal quantum number, is represented by the energy level, which is simply represented by the period. So I'm going to go up to period 2, okay? Up to period 2, and which block am I going to? What block is nitrogen in? P block. So I'm going to draw all of these things with these spaces just like this, okay? Draw all these spaces just like that. So you're not going to draw on that piece of paper I gave you, okay? You're going to draw on, somewhere else. So I'm going to draw exactly how that was. 1s had 1 space, 2s had 1 space, and then 2p. I just drew. That's exactly what my energy level diagram looked like, okay? I'm drawing up to the period, over to the block, okay? Up to the period, over to the block. That makes sense to everyone. All right, so now I'm going to have to follow all my rules, okay? I'm going to have to follow all my rules to draw, to put in the arrows as electrons. The Aufbau principle states what? Electrons are added where first? That's Aufbau principle. At the bottom. So we'll start at the bottom. So I'm going to draw my first electron, and with an up arrow. Okay? That's 1 electron. I've got to draw 7. Now, Aufbau principle tells you, or Hund's rule also tells you can't go to 2s until 1s is full. Okay? So each line can hold 2 electrons. One with an up arrow, one with a down arrow. Okay? So do I now have my 1s orbital full? Each orbital can hold 2 electrons. Do I have it full? Yes. I've drawn 2 electrons, haven't I? So now I need to go, what comes next? 2s. So I'm going to give it an up arrow. Is my 2s full? No, so that means I cannot go to 2p. So I got to fill out my 2s. So I'm going to give it a down arrow. I have now drawn how many electrons? 4. I need how many? 7. So where do I go to next? 2p. Now, here's where you got to follow Hund's rule. What does Hund's rule state? Well, perhaps I have to. So I can't go up, down. I need to go up, up, up. Pretend that's in that orbital right there, okay? How many electrons have I drawn? 7. So that is my orbital notation for nitrogen, okay? That's my orbital notation for nitrogen. I'm not finished, though. For today is something new, okay? We're going to each day, today is going to be shorter than yesterday. Tomorrow is going to be a shorter way of doing it than today, okay? So I want to write my electron configuration. So that's where I am now. I want to write my electron configuration. So my electron configuration uses the quantum numbers to show the arrangement of electrons in the atom, okay? The energy level is indicated by the number, then the shape of the orbital, the number of electrons in the orbital. Here's an example of this, okay? So this one's going to, so it tells you 1 represents first energy level, S represents the angular momentum quantum number, the orbital, 2 represents there's 2 electrons in it. You read it as 1s2, not 1s squared, okay? So back to my problem. I still have to follow my rules, okay? I'm still doing this. So now I want to draw the electron configuration, okay? And this is going to be in words, really, and numbers instead of arrows. So what's my first orbital in this atom? 1s. I'm going to write 1s. Let me erase that and write that a little bit neater. One s. How many electrons are in the 1s orbital? I have 2 electrons, so I'm going to write it. It's going to write it like square, but I read it as 1s2. Okay? What's my next orbital? 2s. How many electrons do I have in it? 2. What's my next orbital? 2p. How many electrons are in it? 3. So, okay. Now, I add up the top numbers. 2 plus 2 plus 3 is what? 7. How many electrons am I supposed to have? 7. So today we're talking about electron configuration, and this is the answer for today. Now, you still have to draw the orbital notation, okay, of those other elements, but I would write it as 1s2, 2s2, 2p3. It's written out. It's a shorter way of doing it as opposed to drawing arrows. Let's do another example. Yes, sir. Yeah, one yesterday you have to draw the arrows. Yes, sir. The one today you have to draw the arrows and the electron configuration. The arrows will get easy. Like you'll catch the hang of after doing 2 or 3. So let's do. I don't want to do Mercury yet because that's on your homework and that's a really far one. Let's do. That's on your homework too. Let's do potassium. Let's do K. It's on your homework too. Let's do K. So I'm waiting for someone to tell me the number of electrons, the period, and the block. Period what? Period 4. Period 4. S block, I heard that. And 19. Oh. No, yeah, 19 electrons. 19 electrons. All right, so now I got to go to my energy level diagram. Everyone see how we got those 3 pieces of information? Everybody good with that? Yes, ma'am. What? Why? When we get done. Okay, when we get done. Okay. But yes, ma'am. All right, so now let's go to energy level diagram. All right, I'm going up to what period? Let me find my mouse again. 4. So I'm going up to period 4. And I'm stopping at which block? S. So I'm not going to write 3D or 4P because I did not get into that. So I'm going to write 1S, 2S, 2P, 3S, 3P, and 4S. Does that make sense to you? Everything below it and everything you went to in that period, okay? So 1S, 2S, 2P, 3S, 3P, 4S. Because that's what block that potassium's in. So I'm stopping in the block that potassium's in. So let's write this 1S space 2S 2P 3S 3P and then 4S. I'll give you a chance to get that written, then I'll come back with you. Hey, Ben asked a very good question, okay? Why don't I draw 3D? Okay, I don't draw 3D, Ben, because that would give me too many. I won't go into it because I stop in whichever block that I'm in. If I would draw 3D, I would have more spaces than I would have electrons, okay? It's a very good question. All right, so where are we going to start from? 1S. I'm going to go up, down, correct? Now where? 2S. Up, down. Now, I'm drawing how many electrons? 4. Now where am I going? Am I going to 3S or 2P? 2P because it's next to it. So what am I going to do there? Up, up, up. And then I'm going to go back and go down, down, down. I've drawn how many electrons? 10. I'm not anywhere near 19 yet. So now I'm going to go to 3S. Up, down. And then 3P, up, 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 down, down, down. Oh, a little word of advice I always have, when you get to the blocks that you're supposed to end with, okay, in period 4, the S block, count how many electrons you have that we see how many more you need. So I've drawn how many electrons? 18. So I need how many more? 1. So I'm going to put an up arrow there. Yes, ma'am, Shakira. However you count. However you want to count. I count 2, 4, 6. As long as you count the electrons. Yes, ma'am. So now I've drawn 19 electrons, correct? So that's the orbital notation for potassium. Now I want to write the electron configuration. Electron configuration is a lot easier, especially if you've already drawn the orbital notation. So what's my electron configuration going to be? 1s2, 2s2. That's a horrible. 1s2. Let me catch up a little bit. 2s2, 2p what? How many electrons are in the 2p? 6. So 2p 6. What's next? And 4s. Now here's the point why I picked this one. It's not just 4s. I know in math you understand an s that had to be to the power of 1. You have to explicitly write the 1. Okay. So as Anaya said, 4s1. Double check mechanism. Add up your coefficients. What do they add up to? 19, since they should add up to. Let's do one more example together. I'm gonna kind of do one of the. Only reason I don't do one on the bottom, Ben, is because I'm a very messy writer with that, and I don't want to leave enough room. But I'm gonna do a longer one than that. You can. All right, let's do molybdenum. The big Mo. Molybdenum. Period 5, the D block. And 42 electrons. Now to my energy level diagram. What's the last orbital I'm going to write? 4D. Why 4D and not 5D? Yes, because it's in period 5. So that's a very common mistake. People want to sit in at 5D because all they see period 5. You look at this diagram, period 1, period 2, period 3, period 4, period 5. Okay? So the D block in period 5 is 4D. Okay? Now, am I going to write 4P? Why? It's below it because it's in period 4 and it's below it. So I'm going to draw this up to 4D. So I've got it drawn. I'll give you just a second to get called back. I'm going to start adding where at the 1S, correct? And I'm going to, where am I going to kind of stop to see where I am? Where would be a good point to stop to see where I am? At which orbital? What's the last orbital I'm going to go into? 4D. So I'm going to fill everything up to 5S. I'm going to fill everything up to 5S, and then I'm going to kind of come together. I'm going to kind of stop and collect myself at that point in time. So up, down. I'm in 2P, up, up, up. Stopped at 5D. Or 4D. We're stopped at 4D. Because I'm going into the D block. So I got to go over into the D block. So the P is up, up, up. And then down, down, down. Up, down. I'll remind you, like I said, this is not something that we explicitly do all the time. This is providing the basis of a lot of things we do in chemistry this way. Even after tomorrow, we're going to shorten it one more way to what we feel is the most important for what we want to do. So I got to fill all the D's, the 3 D's up before I go to the 4 P's. That's where I am right now.
So why did we add P to this one?
Why do we add 4P? Because it's below it. Okay, we didn't add 5P because we didn't go into the 5P. But we had to add the 4P because it's below it because it's a period 4 thing. So I'm at 5S. I've drawn how many? Count that again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 38. 36, 38. So I need how many more? 4. So I'm going to go up, 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 up. Is anything in this last orbital? No. Do I have to draw it? Yes. Because I'm in the D's, so I have to draw all 5D orbitals. Okay, I have to draw all 5D orbitals. So now I'm ready to write my electron configuration. How would I write my electron configuration out? Ten. 2, 4, 6, 8, 10. These hold 10. 4P6. I'm going to run out of room. That's okay. Yep. And I kind of ran out of room, so I'm just going to kind of put it below it. Okay. It's an S for people who can't read my messy handwriting. And then 4D what? If I add up all those coefficients together, they're going to equal 42. No. All right, so that's their homework today. So like I said, if you can draw orbital notation, electron configuration is really just shortened out the same thing. So in today's homework, you need to draw the orbital notation. Yes, sir. On today's homework. Tomorrow's homework, you won't have to. Okay.
But on today's we did it on yesterday we did it.
I want you to draw them on both of them today for extra practice. If you have any questions, please
On yesterday's,
let
you
me know.
rather do this part, though, do you?
Correct. Yesterday, you don't do that.